JPEG 2000 from Wikipedia, the Free Encyclopedia. This article has multiple issues. Please help improve it or discuss these issues in the talk page. Hide. Learn how and when to remove these sample messages. This article may be in need of reorganization to comply with Wikipedia's layout guidelines. January 2008. This article needs to be updated. October 2009. JPEG 2000 JP2 is an image compression standard encoding system. It was created with the Joint Photographics Expert Group Committee in 2000 with the intention of superseding their original discrete Gaussian transform-based JPEG standard created in 1992 with a newly designed wavelet-based method. The standardized file name extension is .jp2 for ISO.IEC 15444-1 conforming files in .jpx for the extended Part 2 specifications, published as ISO/IEC 15444-2. The registered MIME type certified in RFC 3745. For ISO/IEC 15444-1, it is image/JP2. JPEG 2000 QuirbStreams regions of interest that offer several mechanisms to support spatial random access or region of interest access at varying degrees of granularity. It is possible to store different parts of the same picture using different quality. As of 2017, there are very few digital cameras that encode photos in the JPEG 2000 format, and many applications for viewing and editing photos still do not support it. JPEG 2000. Comparison of JPEG 2000 with original JPEG format, uncompressed, 378 kilobytes 1:1. JPEG JF1F, 11.2 kilobytes 1:1 to 33.65 ratio. IJC Q30 and JPEG 2000, 11.2 kilobytes 1 to 33.65 ratio. File name expansion .jp2, .j2k, .jpf, .jpx, .jpm, .mj2. Internet media type image-jp2, image-jpx, image-jpm, video-mj2. Uniform type identifier UTI public.jpeg 2000 developed by Joint Photographics Expert Groups. Type of format graphics file format. Okay. Standard ISO/IEC 15444. Contents Wikipedia, the Free Encyclopedia, article, talk, read, edit, view history not logged in, talk, contributors, create account, login, search Wikipedia, n.wikipedia.org/wiki/jpeg2000, main page, contents, future content, current events, random events, donate to Wikipedia Weekly Store, interaction, help.wikipedia, community portal, recent changes, contact page, tools, what links here, related changes, upload file, special pages, permanent link, page information, Wikidata item, cite this page, print-export, create a book, download this PDF, printable version. Other projects, Wikimedia Commons, languages, Català, Sistina, Dios, Español, Francés, something, Italiano, Netherlands, Polski, Portuguese, Slovakia, Svenska, contents, in brackets, contents, I. Once, aims to start. Improvements over the 1992 JPEG standard. 2.1. Compression ratio. 2.2. Multiple resolution representation. 2.3. Progressive compression by pixel resolution accuracy. 2.4. Choices of lossless or lossy compression. 2.5. Error resilience. 2.6. Flexible file format. High data range support. 2.8. Side channel spatial information. 3. JPEG 2000 image coding system parts. 4. Physical discussion. 4.1. Color components transformation. 4.2. Tiling. 4.3. Wavelet transform. 4.4. Quantization. 4.5. Filtering. 4.6. Compression ratio. 4.7. Computational complexity and performance. 5. File format and code stream. 6. Metadata. 7. Applications. 8. Comparison of PNG formats. 9. Legal status. 10. Related standards. 10.1. JPIP protocol for streaming JPEG 2000 images. 10.2 Motion JPEG 2000. 10.3 ISO based media file formats. 10.4 GML JP2 georeferencing. 11 application supports. 11.1 applications. 11.2 libraries. 12 see also. 13 notes. 14 references. 13 external links. Edit links. 1. Aim to the standard. While there is a modest increase in compression performance of JPEG 2000s compared to JPEG, the main advantage offered by JPEG 2000s is the significant flexibility of the code stream. The code stream obtained after compression of an image of JPEG 2000 is scalable in nature, meaning that it can be decoded in a number of ways. For instance, by truncating the code stream at any point to formulate a representation of the image at a lower resolution or signal-to-noise ratio. See scalable compression. By ordering the code stream in various ways, applications can achieve significant performance increases. However, as a consequence of its flexibility, JPEG 2000 requires encoders/decoders that are complex and computationally demanding. Another difference in comparison with JPEG is in terms of visual artifacts. JPEG 2000 only produces ringing artifacts, manifested as blurs and rings near the edges of the image, while JPEG produces both ringing artifacts and blocking artifacts due to its 8x8 blocks. JPEG 2000 is published as an ISO standard, ISO-IEC 15444. As of 2017, JPEG 2000 is not likely to support the web browsers that is not generally used in the internet. Improvements over the 1992 JPEG standard. Edit. Superior compression ratio. Edit. At high bit rates, artifacts become nearly imperceptible. JPEG 2000 is a small machine measured fidelity advantage over JPEG. At lower bit rates, example, less than 0.25 bits per pixel for grayscale images, JPEG 2000 has a significant advantage over certain modes of JPEG. Artifacts are less visible and there is almost no blocking. The comparison gains for JPEG are attributed to the use of DWT and a more sophisticated entropy encoding stream. Multiple resolution representation. Edit. JPEG 2000 decoded the image in multiple resolution representation in the course of its compression project. This pyramid representation can be put to use for other image presentation purposes beyond compression. Edit. Compare progressive transmission by pixel and resolution accuracy. Edit. These features are more commonly known as progressive decoding and signal-to-noise ratio (SNR) scalability. JPEG 2000 provides efficient code stream organization such as progressive by pixel accuracy and by image resolution or by image size. This way, after a smaller part of the whole file has been received, the viewer can see a lower quality version of the file picture. The quality then improves progressively through downloading more bits of data from the source. Choice of lossless or lossy compression. Edit. Like the lossless JPEG standard, the JPEG 2000 standard provides both lossless and lossy compression in a single compression architecture. Lossless compression is provided for the use of a reversible integer wavelet transform in JPEG 2000. Error resilience. Edit. Unlike JPEG 1992, JPEG 2000 is robust to bit errors introduced by noisy communication channels due to the coding of data in relatively small independent blocks. Flexible file formats. The JP2 and JPX file formats allow for handling of color space information, metadata, and for interactivity in networked applications, as developed in the JPEG Part 9 JPIP file. edit, 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 high dynamic range support, edit. JPEG 2000 supports any bit depth, just 16 and 32-bit floating point pixel images, and color space. Style information, full support for transparency and alpha planes. Top to bottom demonstrations of the artifacts of JPEG 2000. The numbers indicate the compression rates you use. 1 to 1, 1 to 5, 1 to 10, 1 to 20, 1 to 50, and 1 to 100. JPEG 2000 image coding system dash parts. JPEG 2000 coding system ISO-IEC 1544 consists of the following parts. JPEG 2000 image coding system dash parts. Parts number: first public release date, first edition, latest public release date, dated edition. This amendment, identical ITUT standard, title, description. Part 1. ISO.IC 15441 2000, 2004, 2006 T.800 core coding system, the basic characteristics of JPEG 2000 compression.jp2. Part 2. ISO.IC 15444-2 2004, 2004, 2006 T.801 extensions .jpx, .jpf floating points. Part 3. ISO-IEC 15443 2002 to 2007 T.802 Mosin JPEG 2000 .mj2. Part 4. ISO-IEC 15444-4 2002 2004 T.803 conformance testing. Part 5. ISO-IEC 15444-5 2003 2003 2003 T.804 reference software, Java and C implementations. Part 6. ISO-IEC 15444-6 2003 2003 2007 4, 5, 9 T.805 compact image file format JPM. Example: document images are for pre-present fax-like applications. Yes, 1. Shall continue. Part 7. Abandon. Guideline of minimum support function for ISO-IEC 15444-1. Technical report on minimum support functions. Part 8. ISO-IEC 15444-8 2007, 2007, 2008 T.807 Secure JPEG 2000 JPSEC Security aspects. Part 9. ISO-IEC 15444-9 2005, 2005, 2008, 13, and also 12 T.808 Interactivity tools, APIs, and protocols. JPIP Interactive profiles and API. Part 10. ISO/IEC 15444-10 2008, 2008, 2008 T.809 Extensions for three-dimensional data. JP3D Volumetric Imaging. 11. ISO-IEC 15444-11 2007, 2007, 15, 14, 12, 13, 12 T.810 Wireless JPWL Wireless Applications. Part 12. ISO-IEC 15444-12 2004, 2008, 16 ISO-based media file format. Part 13. ISO-IEC 15444-13 2008, 2007, 17, 16 T.812 an entry-level JPEG 2000 encoder. Part 14. ISO-IEC 15444-14, 18, 19 as well as 2 2013 T.813 XML structure implementation and reference. Technical discussion. The aim of JPEG 3000 is not only improving compression performance over JPEG, but also adding or improving features such as scalability and editability. JPEG 2000's improvement in compression performance relative to the original JPEG standard is actually rather modest, and should not be ordinarily the primarily consideration for evaluating the design. Very low and very high compression rates are supported in JPEG 2000. The ability of the design to handle a very large range of effective bit rates is one of the strengths of JPEG 2000. For example, to reduce the number of bits for a picture to a lower serial amount, the advisable thing to do with the first JPEG standard is to reduce the resolution of the input image before encoding it. That's unnecessary when using JPEG 2000 because JPEG 2000 already does this automatically through its multi-resolution decomposition structure. The following sections describe the algorithm of JPEG 2000. According to KB, the current JP2 format specification leaves room for multiple interpretations when it comes to the support of ICT profiles and the handling of grid resolution information. 21. Edit. Color components transformation. Initially, images have to be transformed from the RGB color space to another color space, leading to 3 components that are handled separately. There are 2 possible choices. 1. Irreversible color transform, ICT, uses the well-known YC subscript B C subscript R color space. It is called irreversible because it has to be implemented in a floating or fixed point and causes round-off errors. 2. Reversible color transformation, RCT, uses a modified YUV color space and does not introduce quantization errors, so it is fully reversible. However, implementation of the RCT requires that numbers are rounded as specified that cannot be expressed exactly in matrix form. The transformation is y equals r plus 2g plus b divided by 4, c subscript b equals b minus g, c subscript r equals r minus g, and g equals y minus c subscript b plus c subscript r divided by 4, r equals c subscript r plus g, b equals c subscript b plus g. The components can be, but do not necessarily have to be, downscaled resolution. In fact, since the wavelet transformation already separates images into scales, downscaling is more effectively handled by dropping the new finest wavelet scale. This step is called multiple component transformation in the JPEG 2000 language, since its usage is not restricted to the RGB color model. Tiling. Edit. After the color transformation, the image is split into so-called tiles, rectangular regions of the image that are transformed and encoded separately. Tiles can be any size, and it is also possible to consider the whole image as one single tile. Once the size is chosen, all the tiles will have the same size, except optionally those in the right and bottom borders. Dividing the image into tiles is advantageous in that the decoder will need less memory to decode the image, and it can opt to decode only selected files to achieve a partial decoding of the image. The disadvantage of this approach is that the quality of the picture decreases due to a lower peak-to-signal-noise ratio. Using many tiles can create a blocking effect similar to the older JPEG 1992 standard. Wavelet transformation. Edit. These tiles are then wavelet transformed to arbitrary depth. In contrast to JPEG 1992, which was an 8x8 block size discrete cosine transform. JPEG 2000 uses 2 different wavelength transforms. 1. Irreversible. The CDF 9/7 wavelet transform. It is said to be irreversible because it introduces quantization noise that depends on the position of the decoder. Reversible. 2. Reversible. A rounded version of the bio-orthogonal CDF 5/3 wavelet transform. It uses only integer coefficients, so the output does not require rounding, quantization, and so it does not introduce any quantization noise. It is used in lossless coding. The wavelet transforms are implemented by the lifting scale by convolution, CDF 5/3 wavelet used for loss compression. Quantization. Edit. After the wavelet transform, the coefficients are scalar quantized to reduce the number of bits represented to a sense of quality. Edit. The output is a set of integer numbers which have to be encoded bit by bit. The parameter that can be changed is that the final quality is the quantization step. The greater step, the code is the compression and loss of quality, but the quantization step equals 1. No quantization is performed. It is used in lossless compression. An example of the wavelet transform that is used in JPEG 2000. This is a second level CDF 9/7 wavelet transform. Coding. Edit. The result of the previous process is a collection of subbands which represent several approximation scales. A subband is a set of coefficients, real numbers which represent aspects of the image associated with a certain frequency range, as well as the spatial area of the image. The quantized subbands are split further into precincts, rectangular regions in the wavelet domain. They are typically selected in a way that the coefficients within them across the subbands form approximately spatial blocks in the reconstructed inner domain. Though this is not a requirement, precincts are split further into code blocks. Code blocks are located in a single subband and have equal sizes, except those located at the edges of the image. The encoder has to encode the bits of all quantized coefficients of the code block, starting with the most significant bits in progress to a list of the different bits by progress called the EBCOT scheme. EBCOT here stands for Embedded Block Coding with Optimal Truncation. In its encoding progress, each bit point of the code block gets in 3 sub-code coding passes. First, encoding bits and sides of an insignificant coefficients with significant neighbors, i.e. with 1 bits in higher plane. Then refinement bits of significant coefficients, and finally coefficients without significant neighbors. The 3 passes are called significance propagation, magnitude refinement, and cleanup pass respectively. Clearly, in all lossless mode, all bit planes have to be encoded by the EBCOT, and no bit planes can be dropped. The bits selected by these coding passes then get encoded by a context driven by arithmetic coder, namely the binary MQ coder. The context of a coefficient is formed by a state of its fine neighbors in the code block. The result is a bit stream that can be split into packets, whereas a packet groups selected classes of all code blocks in a precinct form into one indivisible unit. Packets are the key to quality scalability, i.e. packets containing less significant bits can be discarded to achieve lower bit rates and higher resolution. Packets from all subbands are then collected in the so-called layers. The way that packets are built up from the code block coding passes, and this which packets a layer will contain is not defined by the JPEG 2000 standard, but in general a codec will try to break both layers in such a way that the image quality will increase monotonically at each layer, and the distortion will shrink under the layer. Thus, layers define the progression by image quality within the code stream. The problem is now to find the optical packet length for all code blocks, which minimizes the overall distortion in a way that the generated target bit rate equals the demanded bit rate. Well, the standard does not define a procedure as to how to perform this form of rate distortion optimization. The general outline is given by the appendices. For each bit encoded by the EBCOT encoder, the improvements in image quality defined as mean square error get measured. This can be implemented by easy table lookup algorithm. Furthermore, the length of the resulting code stream gets measured. This forms for each code block graph in a rate distortion plane, giving image quality over bit stream length. The optimal selection for the truncation points, thus for the packet product points, is then defined by is then given by defining critical slopes of these curves. Picking up passes whose curve in the rates distortion graph is steeper than the given critical slope. This method can be seen as a special application of the method of language multiplier, which is used for optimization problems under constraints. The language multiplier, typically denoted by lambda, and this turns out to be the critical slope. The constraint is the demanded target bit rate, and the value is to optimize the overall distortion. Packets can be reordered almost arbitrarily in the JPEG 2000 bit stream. This gives the encoders with the image server a high degree of freedom. Already encoded images can be sent over networks with arbitrary bit rates based on the layer progressive encoding order. On the other hand, cooler components can be moved back in the bit stream, where resolutions corresponding to lower frequency subbands can be sent for image previewing. Finally, spatial browsing of large images is possible through appropriate tile and or partition selection. All these operations do not require any re-encoding but only byte-wise copy operations. compression ratio. Edit. Compared to the previous JPEG standard, JPEG 2000 boasts a typical compression grain in the range of 20%, depending on the image characteristics. High resolution images tend to benefit more, where JPEG 2000 spatial redundancy prediction contribute more to the compression process. In very low bitrate applications, studies can be shown JPEG 2000 be outperformed by the interframe coding mode of H.264. Good applications for JPEG 2000 are large images, images of low contrast edges, e.g. medical images. This image shows the accentuated difference between the image saved as JPEG 2000, quality 50%, and the original. Comparison between JPEG 2000, JPEG XR, and JPEG. Computational complexity and performance. 22. JPEG 2000 is much more complicated in terms of computational complexity. With JPEG standard, tiling, color component transform, discrete wavelet transform, and quantization can be done pretty fast, though entropy codec is time consuming and quite complicated. EBCLT context modeling and arithmetic MQ coder take most of the time with the JPEG 2000 codec. On CPU, the main idea of getting fast JPEG 2000 encoding and decoding is closely connected with AVX-SSC and multi-threading to process each tile on a separate thread. The fastest JPEG 2000 solutions utilize both CPU and GPU power to get the highest performance benchmarks. 23, 24. File format and code stream. Edit. Similar to JPEG 1, JPEG 2000 defines both a file format and a code stream. Whereas JPEG 2000 entirely describes the image samples, JPEG 1 includes additional meta information such as the resolution of the image or the cover space that has been used to encode the image. JPEG 2000 images should, if stored as files, be boxed in the JPEG 2000 file format, where they get the JPEG-0 extension. Part 2 is mentioned the JPEG 2000, i.e. ISO-IC 15444-2, also enriches this file format to include mechanisms for animation or composition of several code streams into one single image. Images in this XML file format use the JPX extension. There is no standardized extension for the code stream data because there is no standardization extension for the code stream data because code stream data is not to be considered to be stored in files in the first place. Though when done for testing purposes, the extension .jpc or .j2k appears frequently. Metadata. Edit. For traditional JPEG, additional metadata, example lighting and exposure conditions, is kept in an application marker in the EXIF format specified by the JEITA. JPEG 2000 chooses a different route, encoding the same metadata in XML form. The reference between the EXIF tags and the XML elements is standardized by the ISO TC42 committee in the standard 12234-1.4. Extensible metadata platform can also be embedded in JPEG 2000. Applications. Edit. Some markets and applications intend to be served by the standard listed for. Consumer applications such as multimedia devices. Example: digital cameras, personal digital assistants, 3G mobile phones, color, facsimile printers, scanners, etc. Client-server communication. Example: the internet, image database, video streaming, video server, etc. Military surveillance. Example: HD satellite images, motion detection, network distribution and storage, etc. Medical imagery, ESP, the DICLM specifications for medical data interchange, biometrics, remote sensing, high-quality frame-based video recording, editing, and storage. Live HDTV feed contribution, iframe-only video compression with low transmission latency, such as live HDTV feed out of a sport event linked to the TV station studio. Digital cinema. JPEG 2000 has many design commonalities with the ICER image compression format that uses to send images back from the Mars rovers. Digitized audio, visual content, and images for long-term digital preservation. Worldwide World Meteorological World Meteorological Organization has built JPEG 2000 compression into the new Quirb file format. The Quirb file structure is designed for global distribution of meteorological data. The implementation of JPEG 2000 and Quirb2 has reduced file sizes up to 80%, 25. Comparison of PNG format. Although JPEG 2000 format supports lossless encoding, it is not intended to completely supersede today's dominant lossless image formats. The PNG portable network graphics format is still more space efficient in cases of images manufactured with the same color citation needed, such as diagrams and supports special compression features that JPEG 2000 does not. Legal status. Edit. JPEG 2000 is covered by patients, but the contributing companies and organizations agree that licenses for first part, the core coding system, can, clarification needed, be obtained free of charge from all contributors. The JPEG community has stated it has always been a strong goal of the JPEG community that its standards should be implemented in their baseline form without payments of royalty and license fees. The up-and-coming JPEG 2000 standard has prepared along these lines, and agreement was reached with over 20 large organizations holding many patents in this area to allow use of their intellectual property in connection with the standard without payments of license fees or royalties. 26. However, the JPEG community as an all that's undeclared submarine patents may still present a hazard. It is of course still possible that other organizations or individuals may claim intellectual property rights that affect implementation of the standard, and many implementers are urged to carry out their own searches and investigations in this area. 27. Related standards. Edit. Several additional parts of the JPEG 2000 sound exist. Amongst them are ISO-IEC 15442 to 2008 JPEG 2000 extensions defining the .jpx file format, using, for example, trellis quantization and extended file format and additional color spaces. 28. ISO/IEC 15444-4 2000 to 2000. The reference testing and ISO/IEC 15444-6 2000, the compound image file format .jpm, allowing compression of compound text image graphics. 29. Extensions for secure image transfer, JPSCC, ISO/IEC 15444-8, enhanced error correction schemes for voice applications. JPWL, ISO/IEC 15444-11, and extensions for encoding of volumetric images, JP3D, ISO/IEC 15444-10, also already available from the ISO. JPIP protocol for streaming JPEG 2000 images. Edit. JPEG protocol for streaming JPEG 2000 images. Edit. In 2005, a JPEG 2000 based image processing protocol called JPIP has been published as ISO/IEC 1544-930. Within this framework, only selected regions of potentially huge images have to be translated from the image server on the request of a client, thus reducing the required bandwidth. JPEG 2000 data may be streamed using the ECWP and ECWPS protocols found within ERDAS ECW-/JP2 SDK. Motion JPEG 2000. Motion JPEG 2000 and MJ2. Origin defined in Part 3 of the ISO standard for JPEG 2000 ISO/IEC 15443-2002 as a standalone document has now been expressed by the ISO/IEC 15444-3-2002 AMD 2-2003 implemented the ISO base format ISO/IEC 15444-12 and an ITU-T recommendation T.802-31. It specifies the use of the JPEG 2000 format for time sequences of images. Motion sequences, possibly combined with audio if proposed into an overall presentation. 32, 33. It also defines a file format. 34, based on ISO-based media file format. ISO 1544-12, file name extensions for motion JPEG 2000. Video files are .mj2 and .mjp2 according to RFC 3745. 34. It is an open ISO standard and advanced update to MJPG, or MJ, which is based on the legacy JPEG format. Unlike common video formats such as MPEG-4, Part 2, WMV, and H.264, MJ2 does not employ temporal or interframe compression. Instead, each frame is an independent entity encoded by either a lossy or lossless variant of JPEG 2000. Its physical structure does not depend on time ordering, but it does employ a set profile to complement data. For audio, it supports LPCM encoding, as well as various MPEG-4 variants, such as RAW or complement data. 35. Motion JPEG 2000, often referenced as MJ2 or MJP2, was considered as a digital archival format. 36. The Library of Congress, in June 2013, in an interview with Bertram Lyons from the Library of Congress for the New York Times Magazine about tips on archiving family history, codecs like FFV1 H.264 or Apple ProRes are mentioned, but JPEG 2000 is not. 37. ISO-based media file format. ISO/IEC 1544-12 is identical with ISO/IEC 14496-12 and PIC4 Part 12, and it defines ISO-based media file format. For example, motion JPEG 2000 file format, MP4 format, or 3GP file format are also based on the ISO-based media file format. 38, 39, 40, 41, 42. GML, JP2, georeferencing, edit, edit. The Open Geospatial Consortium, OGC, has defined a metadata standard for georeferencing JPEG 2000 images with embedded XML using geography markup language (GML) formats. GML and JPEG 2000 for geographic image encoding. GML JP2 version 1.0.0 dated 2006-01-18 43 version 2.0 entitled GML and JPEG 2000 GML JP2 encoding standard part 1 core was approved in 2014 06 30 43. JP2 and JPX files containing GML JP2 markup can be located and displayed in the correct position are serviced by a suitable geographic information system (GIS) in a similar way to GeoTIFF images. Application support. Edit. Applications. Edit. Program. Basic. Note 1. Wait. Application support for JPEG 2000. Program. Basic. Note 1. Advanced. Note 1. License. Read, write, ACDC. Yes. Question mark. Proprietary. Adobe Photoshop. Note 2. Yes. Wait. Hold on. Yes. Proprietary. Adobe Lightroom. No. Proprietary. Apple iPhoto. Yes. No. Proprietary. Apple Preview. Note 3. Yes. Proprietary. Autodesk AutoCAD. Yes. Question mark. Proprietary. PA systems come. COMPAT. PASS. Yes. No. Proprietary. Blender. Yes. Question mark. GPL. Phase 1, Capture 1. Yes. Proprietary. Chassis Draw. Yes. Freeware. Cine Asset. Yes, proprietary, Compupic Pro, Compupic Pro, yes, question mark, proprietary, Corel, photo paint, photo dash paint, yes, proprietary, Dominion, 45, yes, no, proprietary, Darktable, JPL, DB Gallery, yes, no, proprietary, Digicam, 4748, KDE 49, 46, 45, yes, GPL, Recognition, yes, proprietary, Envy, yes, proprietary, Erdus, Imagine, yes, proprietary, Events, PDF font profile embedding, yes, no, GPL v2, Fastone Image Viewer, yes, free, yes, freeware, Fastone Max View, yes, no, proprietary, Photographics 2.0, no, proprietary, Photo Sketcher 2.70, no, proprietary, GIMP 2.8, yes, 50, no, no, GPL, Google Chrome, no, proprietary, graphic converter, yes, shareware, Gwenview KDE 49, yes, GPL, shareware, IDL, yes, proprietary, image magic, yes, no, image magic license, Earthen view, yes, no, freeware, color paint, KDE 49, yes, question mark, 2 class BSG, Mathematica, yes, question mark, proprietary, MATLAB, via toolbox, proprietary, 39, I see the Firefox, no, Note 4, no, MPL, Opera, via QuickTime, dash, proprietary, photo filter, 7.1, no, proprietary, photo line, yes, proprietary, pixel image editor, yes, question mark, proprietary, QGIS with a plugin, yes, question mark, JPL, Safari, yes, dash, dash, proprietary, Silverfast, yes, proprietary, XNView, yes, proprietary, ZI proxy, Zproxy, yes, no, JPL. 1. Superscript A, B, caret, basic and advanced support refer to conformance with, respectively, Part 1 and Part 2 of the JPEG standard. 2. Caret, Adobe Photoshop CS2 and CSV's official JPEG 2000 plugin package is not installed by default and must be manually copied from the install disk dash folder to the plugins greater than file formats folder. 3. Caret, tested with preview.f 7.0 and Mac OS 10.9. 4. Caret, Mozilla support for JPEG 2000 was requested in April 2000, but the report was closed as WNTFIX in August 2009. 1. There is an extension that adds support to older versions of Firefox. 2. Libraries. Edit. Library support for JPEG 2000. Program. Basic. Advanced. Language. License. Read, write. Company method. Yes. C. Proprietary. Erdus. ECW JPEG 2000 SDK. Yes. Question mark. C. C++ proprietary. Fast Video SDK. No. Yes. No. C. C++ proprietary. FFmpeg. Yes. Note 1. Yes. Note 1. Question mark. C. LGPL. Rock. Yes. C. C++. AGPL. G2K plus from 2.14. Yes. No. Question mark. No. C/JTK. LGPL. J2K codec. Yes. No. C++ proprietary. Jasper. Yes. Note 2. Yes, no, no. C. MIT license style. Kodaku. Yes, 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 yes. C++ proprietary. Lead tools. Yes, 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 yes. C++.net. Proprietary. OpenJPEG. Yes, 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 yes. C. BSD. POI codec. Yes, yes, no, no. Java. BOI license. 1. Caret. Superscript A, B. Both the decoder and the encoder in FFmpeg are still marked experimental. 2. Caret. Jasper does not handle 16 bits properly. See, for example. See also. Edit. Digital camera. Comparison of graphics file formats. Video compression picture types. DJView. A compression format that also uses wavelets and is designed for use in the web. ECW. A wavelet compression format that compares well to JPEG 2000. High bitrate media transport. QuickTime, a multimedia framework application web browser plugin developed by Apple, capable of encoding, decoding, and playing various multimedia files, including JPEG, files and images by default. Mr. SID, a wavelet compression format that compares well to not 2000. PGF, a fast wavelet compression format that compares well to JPEG 2000. JPEG, JPEG 2000 Interactive Protocol, Wavelet, WebP, an image format related to WebM, support lossy and lossless compression. Notes, edit. 1. Carry. The JPEG still compression standard. BP. Paragraphs 6 to 7. 2. Caret. Superscript AB. JPEG. Joint Photographics Expert Group. JPEG 2000. Retrieved 2009 1101. 3. Caret. IGN Standardization Team. JPEG 2000. ISO 1544. ISO 1544. Retrieved 2009 101. 4. Caret. International Organization for Standardization. ISO-IC 1544-1 2004. Information Technology. JPEG 2000 Image Coding System. Core Coding System. Retrieved 2009 1101. 5. Caret. International Organization for Standardization. ISO/IAC 14444-2004. Information Technology. JPEG 2000 Image Coding System Extensions. Retrieved 2009 1101. 6. Caret. International Organization for Standardization. ISO/IC 14444-2007. Information Technology. JPEG 2000 Image Coding System. Motion JPEG 2000. Retrieved 2009 1101. 7. International Organization for Standardization. ISO/IC 144-4 2004. Information Technology. JPEG 2000 Image Coding System. Performance Testing. Achieved 2009 1101. 8. Carry International Organization for Standardization. ISO 15445 2003. Information Technology. JPEG 2000 Image Coding System. Reference Software. Achieved 2009 1101. 9. Carry 11. Wait, 9. 9. Caret International Organization for Standardization. ISO/IC 1544-6 2003. Information Technology. JPEG 2000 Image Coding System. Part 6. Compound Image File Format. Achieved 2009 1101. 10. Caret International Organization for Standardization. ISC JTC 1 SC29 or WG1 2012-08 JPEG resolution of 22nd WGY New Orleans meeting doc received 2009 1101. 11. Caret 22nd WG1 New Orleans meeting draft meeting report doc 2000-2 08 retrieved 2009-11-01. 12. Caret International Organization for Standardization. ISO/IEC 1544-8 2007. Information Technology. JPEG 2000 Image Coding System. Secure JPEG 2000 2009-11-01. 13. International Organization for Standardization. ISO/IEC 1544-9 2005. Information Technology. JPEG 2000 Interactive Tool APIs and Protocols. Or 2009 1101. 14. Caret International Organization for Standardization. ISO.ISC 1544-10 2008 Information Technology. JPEG 2000 Image Coding System Extensions for Three-Dimensional Data. 2009 1101. International 15. Caret International Organization for Standardization. ISO/IEC 154411 2007 Information Technology. JPEG 2000 Image Coding System. Wireless. 2009 1101. 16. International Organization for Standardization. ISO/IEC 1544-12-2008 Information Technology. JPEG Information Coding System. Part 12. ISO Base Media File Format 2009 1101. 17. Caret International Organization for Standardization. ISO/IEC 1544-13 2008 Information Technology. JPEG 2000 Image Code System. Entry level JPEG 2000 encoder. 2009 1101. 18. Caret International Organization for Standardization. 2007-701 ISO/IEC AWI 1544-4 Information Technology. JPEG 2000 Image Coding System. Part 14. XML Structural Organization and Reference. Achieved 2009 1101. 19. Caret International Organization for Standardization. ISO/IEC JTC 1/SC29 WG1 2009-01-23 Resolutions of 47th WG1 San Francisco meeting. Doc achieved 2009 1101. 20. Resolutions of 41st WG1 San Jose meeting. Doc 2007 40427 achieved 2009 1101. 21. Caret Johann van der Kniefje. JPEG 2000 for long-term preservation. JP2 conservation format. DOI 10.10 45/May 2011. Van der Knief. 22. Caret Halbach Thiel. July 2002. Performance comparison. H.26L intro coding versus JPEG 2000 PDF 2008 422. 23. Caret S video September 2016 JPEG 2000 performance benchmarks in GPU 2016 90124 Campeonato September 2016 JPEG 2000 performance specification G 2016 901 25. Caret W Group 2 homepage. 26. Caret JPEG 2000 consideration patent claims Archive 2007-07-14 at the Wayback Machine. 27. Caret JPEG 2000 community drafts Archive 2006-07-02 at the Wayback Machine. 28. Caret International Organization for Standardization 2004 ISO/IEC 1544-2/2004 Information Technology. JPEG 2000 Image Coding System. Extensions of G 2009 11. 29. Caret International Organization for Standardization 2003 ISO/IEC 1544-6 2003 Information Technology. JPEG 2000 Image Coding System. Part 6. Compound image file format. Achieved 2009 06-11. 30. Caret International Organization for Standardization 2005 ISO/IEC 1544-9 2005 Information Technology. JPEG 2000 Image Code System. Interactive with Tools, APIs and Protocols. 2009 06-11. 31. Caret T.802 Information Technology. JPEG 2000 Image Coding System. Motion JPEG 2000 January 2005 2009 1101. 32. Caret International Organization for Standardization 2007 ISO/IEC 1544-3/3007 Information Technology. JPEG 2000 Image Coding System. Motion JPEG 2000 G 2009 06-11. 33. Caret JPEG 2007 Motion JPEG 2000 Part 3 Achieved 2009 1101. 34. Caret ITU-T T.802 Information Technology JPEG 2000 Image Growing System built in JPEG 2000 summary retrieved 2010 09 28 35 Motion JPEG Motion JPEG 2000 Part 3 36 Motion JPEG 2000 MJ2 file formats sustainability of digital formats Planning for Library of Congress collection 37 New York Times interview with Burt Lyons LLC about tips on archiving family history June 2013 38 International Organization for Standardization April 2006 ISO-based media file format white paper proposal archive.org archive from the original on 2008-07-14 retrieved 2009-12-26 39 International Organization for Standardization October 2005 MPEG 4 file format white paper proposal archive.org archive from the original on 2008-01-15 retrieved 2009 2012-26 40 International Organization for Standardization October 2009 ISO-based media file format white paper proposal Chirguioni.org retrieved 2009 12-26 41 International Organization for Standardization 2004 ISO/IC 14496 -12 Information Technology Coding of Audio Visual Objects Part 12 ISO-based report file format retrieved 2009-06-11 42 International Organization for Standardization 2008 ISO/IC 14412 2008 Information Technology JPEG 2000 Image Growing System Part 12 ISO-based media file format retrieved 2009-06-11 43 Superscript A B Open Geospatial Consortium GML JP2 GML JP0 homepage 44 Blender 2.49 2009-05 30 archive from the original 2009 06-11 retrieved from 2010 01 20 25 45 Dominion 46 the Dark Table Project 47 the Digicam Handbook Support File Formats Docs KDE.org retrieved 2701 20 48 the Show Photo Handbook Support File Formats retrieved 2010 01 20 49 Superscript ABC Development / Architectural / KDE3 / Imaging and Animation retrieved 2010 01 20 50 the GIMP Team 2009 08 16 GIMP 2.7 Release Notes retrieved 2009 11 17 References Edit Official JPEG 2000 page Final Committee of Drafts of JPEG 2000 Standard. As the official JPEG 2000 standard is not freely available, the final drafts are the most accurate freely available documentation about this standard. Gormish Notes on JPEG 2000 Technical Overview of JPEG 2000 PDF Everything you always wanted to know about JPEG 2000 published by Into Pix in 2008 PDF External links Edit RFC 3745 MIME type registrations for JPEG 2000 ISO/IC 1544 official JPEG 2000 website all published books about JPEG 2000 side-by-side comparison of appearance of 16K JPEG and JPEG 2000 files JPEG and JPEG 2000 artifacts from TIFF to JPEG 2000 from TFF to JPEG 2000 JPEG 2000 for long-term preservation JP2 as a preservation format. What is the current status of software support for JPEG 2000? Is JPEG 2000 really a good preservation format? VT graphics file formats raster ANI, ANA, APNG, ART, BMP, BC, CL, CN, CPC, DTS, DPX, ETL, BCL, FTS, Flick, Flick, VPX, GIF, GIF, HDRI, HVFC, ICR, ICN, ICO, Curve, ICS, ILBM, JPEG, JPEG2, JNG, JPEG, JPEG 2000, JPEG LS, JPEG XR, KRM, MNG, NIFF, NRDDD, OR, PM, PBM, BPM, PNM, CPC, PGM, PPM, PNM, PCS, PGE, PSE, TOR, PNG, PSD, SS, PSP, PSP, QTBR, RS, RB, JPEG 8/AVR, log TIFF, SGI, TJ, TFF, TFF/EP, TFF/IT, UFO/UFP, WWP, WebP, XBM, XCF, XPM, XWD, RAW, CIFF, DNG, Vector, AI, CDR, CGM, DXF, EVA, EBM, Gerber, HVIF, IGES, PTML, SVG, VML, WFSR, Compound, CDF, DJ Boo, EPS, PDF, PICT, PS, SWF, XAML, related, exchangeable file format, extensible metadata platform, XMP, category comparison. VTE, Consultative Committee for Space Data Systems. Data compression, images, ICR, JPEG, JPEG, JSON, 122.0.b1, data, adaptive entropy filter. Error correction, current, binary Gaulier code, concentrated codes, turbo codes, proposed, LDPC codes. Telemetry command uplink. The command last time over set. Proximity 1 space link protocol. Telemetry downlink. Spacecraft monitoring and control. Beacon mode service. Telemetry general space communication profile specifications. SCPS. Performance enhancing proxy. Telemetry modulation systems. Current BPSC. SK. QPSK. OQPSK. Proposed GMSK. Frequencies, X band, S band, K subscript U band, K band, K subscript A bands. Networking interoperability, and monitoring. Service-oriented architecture. Message abstraction layer. VTE, multimedia compression and container formats. Video compression, ISO/AC, MJPEG, Motion JPEG 2000, MPEG-1, MPEG-2, Part 2, MPEG-4, Part 2/ASP, Part 10/AVC, MPEG-H, Part 2/AVC, ITU-T, H.1 to H.621, H.622, H.623, H.624, H.625, SMPT, VC-1, VC-2, VC-3, VC-5, others, Apple Video, AV1, AVS, Bing, Snapback, Dala, Dirac, DV, TVI, FFF1, Huffy of Indio, Library of Microsoft Video 1, MCU Lossless, Almost Video, Pixelit, ProRes 422, ProRes 444, QuickTime, Animation Graphics, Real Video, RT Video, Sheer Video, Smacker, Sorensen Video, Spark, Fiora, Thor, BP3, BP6, BP7, BP8, BP9, WMB, SCB, YULS. Audio compression. ISO/IC, MPEG-1, Layer 3, MP3, MPEG-1, Layer 2, Multi-Channel, MPEG-1, Layer 1, ACC, H3 ACC, AAC, HEAAC, AAC, LD, MPEG Surround, MPEG-4, AOS, MPEG-4, SOS, MPEG-4, DST, MPEG-4, HVXC, MPEG-4 CLP, MPEG-D, US, AC, MPEG-H, 3D audio. ITU-T, G.701, ALA, Mu, Mula, G.718, G.719, G.722, G.722.1, G.722.2, G.723, G.723.1.1, G.726, G.728, G.729, G.729.1, IATF, Opus, ILBC, 3GPP, AMR dot dash WB, AMR dash WB plus, EVRC, EVRCB, EVS, GSMHR, GSMA, GSMHR, GSMFR, GSMEFR, GSMEFR, others. ACEOP, AC3, AC4, AL, AC, SL, A-Track, Codec 2, DRA, DTS FLAC, ISAC, Monkey Audio, TTH, True Audio, MT9, Music Pack, Use Pack, OptimProg, OSQ, QSELP, RCELP, View Audio, RT Audio, STDO, SNH, SOAK, Siren, SMB, Speaks, SVOC, SVLPC, Twin VQ, VMR, WB, Forbes, VSOAP, Wipe, LabPack, WMA, NQA, AppDex. Image compression, IC, ISO, ITU-T, W3, ITF, CT, ITT, Group 4, GIF, HCIF, HEVC, JPEG, JPEG2, JPEG 2000, JPEG XR, lossless, JPEG, PNG, TIF, TFF/EP, TFF/IT, others, APNG, BGB, DJBoo, XR, EXR, FLIF, ICER, MNG, PGF, QTVR, WMP, WebP. Containers, ISO/IC, MPEG-ES, MPEG-BAS, MPEG-PS, MPEG-TS, ISO base media file format, MPEG-4, Part 14, MP4, Motion JPEG 2000, MPEG-29, Part 9, MPEG media transport, ITU-D, H.222.0, T.802, IATF, RTP, others, 3GP and 3G2, AMV, ASF, AIF, FF, AVI, AU, BGP, BINC, Smacker, BMP, DivX, Media Format, EVO, Flash Video, GXF, IFF, M2TS, Troska, WebM, MXF, OGG, QuickTime File Formats, RAT, DVD, Roommeter, Riff, Wave, Mod, and Todd, VOB, IFO, and BUP. IFO and BUP. Collaborations, NET, VC, Alliance for Open Media, and PEG-LA. See compression methods. The methods and compression software for codecs. VT, ISO standards by standard number. One to 99. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 9, 16 to the 1, negative 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 9, negative 10, negative 11, negative 12, negative 13, 128, 216, 2017, 217, 266, 228, 233, 259, 269, 302, 306, 428, 518, 519, 639, negative 1, negative 2, negative 5, negative 646, 697, 732, 764, 843, 898, 965, 1000, 1004, 1007, 1073-1, 1004, 1413, 1536, 1749, 1989, 2014, 2015, 2022, 247, 2108, 2945, 2146, 2248, 2289, 2709, 2711. 2711, 2788, 2852, 329, 3103, 3166, negative 1, negative 2, negative 3, 32, 97, 33, 07, 36, 02, 38, 64, 39, 01, 39, 77, 44, 40, 31, 40, 57, 4, 42, 17, 49, 09, 32, 18, 52, 40, 52, 18, 54, 28, 57, 75, 57, 76, 58, 50, 5, 800, 5, 9, 6, 4, 6, 1, 6, 6, 6, 3, 4, 4, 6, 3, 4, 6, 68, 5, 6, 4, 25, 6, 4, 29, 6, 4, 38, 6, 5, 23, 6, 7, 0, 9, 7,001, 7,002, 7,098, 7,185, 7,200, 7, 4, 9, 8, 7, 0, 3, 6, 7, 8, 0, 10. Wait, no, 7, 8, 10, 7, 8, 11, 7, 8, 12, 7, 8, 13, 7, 8, 16, 8,000, 8, 1, 78, 8. 2000, 10, 4, 8, 7, 7, 6, 7, 8, 10, 7, 8, 11, 7, 8, 12, 7, 8, 13, 7, 8, 16, 8,000, 8,000, 1, 7, 8, 8,000, 17, 8,000, 1, 7, 8,000, 1, 78, 8,217, 8,571, 8,583, 8,600, 8,601, 8,632, 8,652, 8,691, 8,807, 8,820-5, 8,859. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 8 dash L, negative 9, negative 10, negative 11, negative 12, negative 13, negative 14, negative 15, negative 16, 8,879, 9,001, 9,075, 9,126, 9,293, 9,241, 9,362, 9,307, 9,506, 9,539, 9,564, 9,500, 9,564, 9,594, 9,000, 94, 9,660, 9,897, 9,899, 99, 9,949, 9,984, 9,985, 9,985, 10,000 to 19,999, 10,000, 10,005, 10,600, 7,116, 10,108, 1,160, 10,160, 61,165, 10,179, 10,206, 10,21, 8, 10,33, negative 11, negative 21, negative 2, negative 28, negative 38, 10,38, 3, 10,48, 7, 10,55, 5, 10,59, 10,58, 5, 10,64, 6, 10,68, 66, 66, 10,66, 4, 10,74, 6, 10,86, 1, 10,95, 7, 10,96, 2, 10,96, 7, 11s, 11,07, 3, 11,17, 0, 11,17, 9, 11,44, 11,15, 44, 11,17, 83, 11,17, 84, 11,17, 85, 11,81, 11,89, 11,94, 0, negative 2, 11,94, 1, 11,94, 1, TR, 11,99, 2, 12, 006, 12, 182, 12, 27, 12, 23, 4-2, 13, 21, 1, negative 1, negative 2, 13, 21, 6, 13, 25, 0, 13, 39, 9, 13, 46, 2, 13, 39, 13, 40, 48, 5, 13, 40, 90, 13, 490, 13, 5, 6, 7. 13, 5, 6, 8, 13, 58, 4, 13, 61, 6, 14, 14,000, 14, 14,031, 14,224, 14,28, 9, 14,39, 6, 14,44, 3, 14,49, 6, negative 2, negative 3, negative 6, negative 10, negative 1, negative 2, negative 4, negative 7, negative 20, 14,644, 14,649, 14,651, 14,698, 14,750, 14,764, 14,882, 14,971, 15,022, 15,022, 15,189, 52, 15,288, 15,291, 15,292, 15,398, 15,408, 15,444, negative 3, 15,44, 5, 15,43, 8, 15,54, 15, 51, 1, 1568, 6, 15,693, 15,706, negative 2, 15,707, 15,897, 15,901, 919, 15,924, 15,926, 15,926, work in progress or WIP, 15,930, 16, 023, 16, 282, 16, 166, 12-2, 16750, 16949, TS, 17024, 17025, 17100, 17203, 17369, 17442, 17799, 18,000, 18,004, 18,014, 18,2405, 18629, 18916, 19,005, 19,011, 19,002, negative 1, negative 2, 19,114, 19,115, 19,125, 19,136, 19,439, 19,500. 19,501, 19,502, 19,503, 19,505, 19,506, 19,507, 19,508, 19,509, 19,510, 19,600, 2014, 19,752, 19,797, 19,770, 19,775-1, 19,794-5, 19,831, 2,000 plus, 2,000, 20,000 plus, 20,000, 20,022, 20,022, 21,21, 2,400, 21,000, 21,047, 21,500, 21,827, 2,002, 220,000, 23,270, 23,271, 23,36, 0,2545, 1,7246, 2,245, 1,7246, 13,246, 17,24707, 25, 178, 25,964, 26,000, 26,300, 26,324, 27,000 series, 27,000, 27,001, 2,000, 27, 27001, 2005, 27001, 2013, 27002, 27006, 277, 277, 2008, 28,000, 2910, 2000, 148, 2919-2, 29,500, 30,170, 31,000, 32,000, 38,500, 4,500, 420, 10, 55,000, 80,000, negative 1, negative 2, negative 3, category. So that's list of ISO standards, ISO organizations, ISO standards. ISO standards percent number. VTE, list of international electrotechnical conversion standards. IC standards. IC 6 60027, IC 60034, ICC 60,138, ICC 662, IC 63, IC 660, IC 60112, IC 60228, IC 69, IC 16,2097, IC 6309, IC 6320, IC 36364, IC 646, IC 6549, IC 6601, IC 6878, IC 878. 870-5, IC 86870-6, IC 68906-1, IC 6908, IC 6999, IC IC 6958, AES3, AES3, S/PDF, IC 61030, IC 61131, IC 61131-3, IC 61118, IC 61162, IC 61334, IC 61346, IC 61345, IC 61400, IC 619, IC 6150, IC 6150, IC 61850, IC 61880, IC 6198, 6, IC 619 ISC 620, IC 62014-4, IC 6256, IC 22061, IC 66, IC 62196, IC 62262, IC 26664, 62264, IC 62304, IC 62325, IC 62351, IC 62365, IC 62366, IC 2637, IC 26386, IC 264455, IC 26680, IC 62682, IC 627 62700, ISO/IC standards, ISO/IC 6x6, ISO/IC 2022, IC/IC 5258, 5218, ISO/IC 6429, ISO/IC 6523, ISO/IC 7810, ISO/IC 7812, ISO/IC 7813, ISO/IC 7816, ISO/IC 7942, IC 8653, IC so IC 6832, IC 6852, ISO says IC 8859, ISO says IC 9126, ISO says 9293, ISO says IC 9592, ISO says IC 95993, ISO says IC 989, ISO says IC 9949, ISO says 99995, ISO says IC 121, ISO IC 1016, ISO IC 10169, ISO IC 10179, ISO IC 10646, ISO IC 10967, ISO IC 10172, ISO IC 10179, ISO IC 11414, ISO slash ISC 11544, ISO IC 11801, ISO IC 12207, ISO IC 13250, ISO IC 13346, IRC 345 13522-5, ISO IC 1356, ISO IC 13818, 14443. ISO says IC 14496, ISO IC 14482, ISO says IC 15228, IC 1525291, ISO says IC 15448, ISO says IC 15444, ISO 15444, ISO says IRC 15445. ISO IRC 54504. ISO IRC 514511. ISO IRC 15693. ISO 16262. ISO IRC 17026. ISO IRC 172025. 18,000. ISO IRC 18,000 or 18,000. ISO IRC 18,014, ISO IRC 19,792, ISO IRC 19,757, ISO IRC 19,770, ISO IRC 717288, ISO IRC 20,000, ISO IRC 21,000, ISO IRC 21,827, ISO 20,003, ISO IRC 23. I see 20,000, 20,000, 20,360, ISO ISC 24,707, ISO ISC 24,700, 24,720, ISO ISC 24,744, ISO ISC 2,600, ISO slash 2700, ISO wait, ISO 2600, ISO 2700, IS ISC 2700 series, ISO ISC 2702, ISO 132704, ISO 29945, ISO ISC 33001, ISO ISC 42010, ISO ISC 80,000, ISO ISC 38500, ISO ISC 4909, related, International Electrotechnical Commission. Categories: ISO IC standards, ITU-T recommendations, graphics file formats, wavelets, image compression, open formats. This page was last edited on 23 June 2017 at 17:05. Text is available under the Creative Commons Attribution Share Alike license. Additional terms verified. By using this site, you will agree to the terms of use and privacy policy. Wikipedia registered is a registered trademark of the Wikimedia Foundation Inc., non-profit organization. Privacy policy about Wikipedia. Disclaimers. Contact Wikipedia. Developers. Wiki statements. An overview. A Wikimedia project. Powered by MediaWiki. It's an hour and a half of my life I'll never get back. Reading the JPEG 2000 Wikipedia article. Now, the original joke was to have no chat interaction and close all of my socializing things like Skype and Steam, so that I would add to the feeling that I was just alone here, just reading this, even though it's a chat like going away, flipping this. But I wanted to keep the whole like monotone thing the entire way through. But these last couple of things, I think deserves me to actually stop doing that and just say thank you to this entire chat. This beautiful, beautiful chat. Every single one of you, thank you. What a good documentary Gaius 224 for Sound Senses. What a good documentary indeed. I'm proud. I'm proud. Not one of this. I need that. I flippin' need that. Thank you. Again, thank you all again. This will go on YouTube shortly afterwards. Maybe tomorrow if I can't do it right now. But holy flipperoni. Wait, Quirby says the Weeaboo 27. What do you want? Thank you. Thanks to viewers like you. Thank you. I deserve this. What is this? I have to put my headphones on. By the way, I got my headphones on during all of this. Let's see here. I put the theme back. Oh god, look at all this interaction. Everyone's trying to like make sure I'm alive. Jesus, Nick, slow down, man. Milestone, man. What are you streaming? Balls, stop before you die. Oh no. One more like. One more like. Hold on, I got a song. Get memes. Okay, we're just checking links now. That wasn't me. IRL. Good night, Quirby. Hold on, I got a song. Let's see here. It was better than the book? I hope so. I know there wasn't another link in here, but I think. He needs memes. He's gonna have PTSD after this. Yeah, no fuck. Shaggy, this isn't weed. Put links in chat, quick. I wasn't another confuzzled Shaggy. Wait a second. I'm trying to just go through everything that I missed here because I was trying to purposely avoid chat and everything just to try to add to the experience. But you know, consider this the after stream party. It's not a party. My voice hurts after reading it out. Who knew there could be so many IEC standards? Many a kek was made that day. Okay. Don't crash on me now, okay? Come on. Come on. Ah, yes, the quality. That is, Microsoft Edge. Come on. There you go. I can't believe I watched the whole thing, XD. Same here. Back of Sued. And was it. There's the song. Final one. Final one. One. Okay, I'm getting. I like Bowser's story better than Superstar Saga. Yeah, I like Parties in Time, but opinions. This was great and the story is deep. So you must be you can stop anytime. Yeah, I think I'll just stop that about 3 seconds in, like you just did. Because I am on the verge of dying from dehydration after talking for so long. Okay. Force number second favorite, LOL. I think that will be my final goodbye because I'm about. My voice is about to die. Lol. Yeah. Say your final goodbyes to Corbel. I like how you could fight Shujin doesn't, so bye. What's going on? You missed an hour and a half of the best thing ever. Bye bye.